Right, what have we got? As usual, a pack of stuff with a quick start guide in probably. Let's see what's in there. So we have, the Lulzbot TAS 6 quick start guide, which we'll go through shortly. It tells you about everything to do with unboxing and setting up the printer. This is safety and warnings, and various other paperwork that's about what's inside and the sort of QA check when it's packed and shipped to check it's all been signed off and all the things are in the box. Lots of ticks on a thing there. We've got the Lulzbot TAS 6 operation manual, which is a more detailed guide. Nope, sorry, no, it is in fact. Start here, operation, and the actual user manual, so 3 manuals there, presumably with varying levels of detail, and this one seems to go through, all of the detail of the control panel and Cura and so on. Right, let's get this out of the box completely. In fact, I should look in the Start Here guide to see what it says. The Lulzbot manuals are particularly good at telling you what to do and all about the printer. This is the quick start guide, so it tells you exactly what to do. There should be an arrow there so you can lie the printer down, which is in fact there, so it lies down the other way. And it tells you exactly how to take all of the pieces out of the box and goes through the assembly, so I'm going to follow this through and unpack everything. There's my arrow, so this slides out this way. Alright, next we need to take this out. We can get this part out. There we go. Take this foam off here. Right, let's put this up on the table again. Also in the box are 2 smaller boxes, and in those are the actual tool head for printing, which we'll have a look at shortly. And in the other box, we've got various accessories, including power and USB cables, the test print that was done on this printer before it was shipped, and there's also what appears to be the toolkit, which you usually get with these printers so you can maintain it. But let's get this set up and then we'll see what we need these for. The next part of the manual here shows removing the cardboard and getting the print bed part out, so looks like I just need to take the tape off, which is just for transit. And then we should be able to take the cardboard off the bottom. Oh, there we go, whoops. Alright, let's look at the other half. Here's the main part of the printer, so I'm going to quickly look over this before we assemble it. So basically it's all made of 2020 extrusion, as with the previous TASes. The corners here are now metal. These are actually machined parts. Looks like these top parts are 3D printed. The rest of the brackets holding it are now metal, machined or cut in some way, and all the electronics are now contained in this enclosure, including the mains power supply and everything else. So if we just turn this round, we should be able to see that what we've got here is all of the connectors are wired in behind this panel for the extruder, obviously the X-axis and everything else, and these wires just poke out here, so they're ready to be plugged in. We've also got the connector there, which is for a second extruder, which will just plug in. So the TAS 5 had these various connectors. Looks like we've just got one now for the extruder and everything's wired in, and just the main socket there for the outlet power. The Y-axis is held on these 4 bolts, which is the other part we unboxed, and the manual says to take these off, which they should just unscrew. And then we can mount the other axis in, and of course the connectors for the heated bed and the Y-axis are these cables that we've got here, which are labelled on the back of the machine. Now we can fit the Y-axis, which just slots in here, and you'll find it's got 4 brackets, 2 at the back there, that mount onto those posts where the screws are. Just need to make sure we put the wiper here and this extra sensor on the left-hand side. I've done up my 4 bolts, including the 2 at the back, so we now need to connect the cable here to the Y-axis stepper, which is a little bit fiddly. That should plug right in there. There we go. There's just one remaining cable to connect, which goes onto the side of the bed. So I just need to connect those 3 connectors up, and obviously they're different, so then you go in one place. So that one, that goes in there, and that goes in there, and then this piece secures into this little clip on the side of the bed there. It's time to put the tool head on, so let's take that out of its box. So this is the actual print head. It's got the hexagon all-metal hot end, as with the previous generation of TASs. We've now got 2 fans, in fact, to help cool the print where that's required. So we previously had just one on one side, and now we've got them on both sides, which is quite good. We've also got this bigger fan on here, which is got a nice shroud that goes around the cold end or the heat break. And previously they used tiny fans blowing across a heatsink, but now we've got this big fan and a shroud pushing all of that air onto it. So there we can see the heatsink at the back there, which is to keep heat just down at the bottom of the nozzle. So these hot ends go up to 300 degrees, so you can print nylon and polycarbonate. And I believe this is shipped with a 0.5mm nozzle. Yes, it is. So we've got a 5 written on the nozzle there. Don't know if you can just see that. And of course, we've got the 1 screw swap option here. So we put 1 screw in, and this tongue fits into the carriage mount, so you can easily swap out the tool heads pretty easily with 1 screw to put in dual extruders or a flexi extruder as an upgrade. We now need 1 tool from the Lulzbot toolkit that's supplied, so let's see what's in there. So, how does this open? Oh, there's another zip. Right, so we have the clam knife, which is for removing prints from the bed. Various other tools, so normally there's a little wire brush, some tweezers, a spike tool and a scalpel. We've also got a little measuring ruler and some pointy pliers, and this is what I want, which is the complete set of Allen keys, which are for doing the screws up should you have to. Oh, and there's also some replacement wiper pads, which are for the wiper pad, which is for cleaning the nozzle. With the correct Allen key from the set, I'm able to undo the 1 screw there. Just make that loose, and there we go, get that all the way out. In the bottom of that mount is a kind of groove there that the tongue on the bottom of the tool head goes in. So we should be able to just pop that in there and then do up the 1 screw on the top that holds that in place. So we'll do that screw back up there. And then we just need to plug in the cable. So the cable here's got a bit of foam on we can take off. And there's a green arrow and a green arrow, and those 2 should just plug together. The last thing is to attach the filament guide, so we have this handy thing here that pops out to put the spool of filament on, and this little piece here, and supplied is this tube which you feed the filament through, and that is going to clip on there, and this tube guides the filament down to the hot end. The printer is now completely together. The last things in the box are an SD card, a Lulzbot sticker, a USB cable, and a reel of Lulzbot green NGen filament for testing. I've already connected the power cable to the outlet power, so now if I switch this on, it should power up and tell us it's a Lulzbot TAS 6. And there we go, and we've got the menu we can operate with the control panel. So this is the end of the quick start guide, and it now says to proceed to the operation guide, which talks us through connecting the printer to USB, and it tells us about using Cura to do our first print. So there we go. But first of all, I'm just going to auto home the printer and we'll have a closer look at the mechanics. I'm just going to auto home the printer, which is on the movement menu here. So we should be able to see the axis moving now, and it should bring the Z carriage all the way down so we can see those lead screws turning. So the lead screws on here for the Z axis are in fact proper CNC lead screws. They're not studding or anything like that, and that's been the case for several Lulzbot versions now. There's a stepper motor in the bottom of each one that you should be able to see just at the bottom, bringing that carriage down. They've now upgraded the X-axis bars to 12mm, and the Z-axis ones are still 10mm, so that's a slight upgrade from the previous versions of TAS. You can see that now auto-homing. There's this additional sensor here for the Z end stop, so it should hit that in a couple of seconds and stop. And this printer actually does auto leveling, so it has this wiper that cleans the nozzle, and then when we print it touches the corners here of each of the corners of the bed so that it should auto home and auto level, so we don't have to level the bed at all, rather like the Lulzbot Mini. The operation manual tells you to connect this with USB now to Cura and heat up the hot end using Cura to go and put in the sample filament or whatever filament you want. I'm actually going to do that through the control panel. which I can do by going to temperature and going to nozzle and heating that up to 230 degrees. And normally it would auto heat once you'd sliced the part in Cura and put it on the SD card or printed over USB. And it will do everything automatically, but obviously when we need to change the filament, we just want to heat up the nozzle, pull out the old filament and put in some new. So we'll just wait for that to heat up. The display is actually telling me what the temperature is, 31, 33 and rising. And obviously the metal hot end right at the bottom gets really hot. So we have to be careful for that. We'll wait for that to heat up and pop in the new filament. To change filament, you just need to get the idler back, and it's got these two little screws that tension it, but we can just flip that open and open the idler, and then we should be able to pull out the old filaments. There it goes, it's a bit melted at the bottom. And I've already fed the new filaments down my tube, so I should be able to just poke that in. There's a hole in the bottom of the extruder that it goes down into the hot end. I should be able to poke that in and push a bit through. You can see it oozing. We'll have a look at a different camera angle in a minute. And then just shut that idler again. You can just tension it up if you want a little bit, just to make sure it's nice and tight and that the extruder grips the filament. There's some filament oozing out of the hot end there, but if I go on the control panel to the movement menu and go and move the extruder by 1 millimetre at a time, then you should be able to see that extrudes some filament out. There it goes. So that means it's all up to temperature and it's working fine. So now we can cool down the printer and we can go and slice a part in Cura and print it from the SD card. It's always best to get the latest version of Cura from lolspot.com/Cura, which is the Lolspot version of Cura, and Cura of course is open source and it's available for various operating systems, which we've got here. So I've got Windows here, so I've already got the Windows version. There's an install guide here and the link to download is right at the top here. The latest version of Cura at the time of recording is 19.12, which should have all the printer profiles in for the latest printers, including the TAS 6. So the printer of course is open source, and the SD card that comes with it has loads of stuff on, including the production parts, so you can actually print spares for your printer should you wish to. It's unlikely you're going to break anything, but we've actually got all of the pieces there that are 3D printed. And also on there are some sample prints, so I'm going to have a look at, let's see what we've got here, the Roctopus, which is a standard kind of test print. So I'm just going to drag that STL into Cura. There we are, and I can swivel that all around. Now I'm just in simple mode here, so we've got NGen as the option here, as well as PLA and various other materials. We can, of course, select expert mode, which takes us into full settings, and that gives us various things we can change. For now I'm just going to go back to quick print. I'm going to select NGen as the filament and standard, and you can see now I've got the model. It's sliced that, and it gives me the option to save G-code. So if I go and put that onto E, it should output the G-code there, and then we should see that if we go back to the root of that SD card, we've now got the Roctopus G-code on there. As I said before, the operation guide actually advises you to connect the printer to your PC with a USB cable, and in that case the save to SD card option disappears and you get this control panel option. So you can move all the axis round, and then eventually you can just click on print, which is the print button that appears on there, and off it goes and prints. I find that I tend to print off SD card because if Windows crashes it ruins the print otherwise, whereas if I pop the SD card in the printer and print off SD, then the printer just deals with it all itself and it's not dependent on a Windows operating system. I've inserted the SD card in the side of the machine, and now it's as simple as just going to the menu and saying print from SD and selecting Roctopus G-code. And then the printer should auto home, auto level, clean its nozzle, do all of the stuff and go off and print the part. So I'll now sit there heating up for a bit. Looks like the target is 160, and then it's going to wipe that nozzle before it goes and touches the corners. And then it will work out in software whether the bed is level or not, and then it should print perfectly level on the bed. I've already used the tweezers to clean any excessive ooze off the bottom of the nozzle. Obviously it gets to 230 degrees in this case, so obviously make sure you use tweezers. It does auto wipe the nozzle, but it's best to get any really big bits of ooze off before it does so, which will save your cleaning pad. Okay, so it's up to temperature, and now it appears to be auto homing on that sensor. Doing a little retraction to hopefully remove any ooze that might appear on the nozzle. And the next part should be coming and wiping the nozzle on that felt pad to make sure it's nice and clean. There we go, and now it should probe all of the corners to auto level the bed. So it goes down, they conduct electricity, so it's quite important that nozzle is clean, and to keep that felt pad clean, which is why you get spares, so it very gently goes down and touches each nozzle, and it should do all of them in order. So it should now come across and do this one. Just move that filament out of the way. And once it's probed all four of them, it works out in its own firmware running on the printer how level the bed is. Previously you had little screws in the corner of the bed and you had to do that manually by going and putting the nozzle down in each corner and sort of measuring the distance by putting a piece of paper or something underneath. So now all of that has become automatic. This is the same as the Lulzbot Mini. And that should be the last one. So once it's done that, it should bring the nozzle forward again, heat it up to temperature for printing, heat the bed up, which actually is already almost up to temperature according to the control panel, and then off it should go and print. So that's just heating up now. The target is 230 on the control panel, the bed at 85 for NGen. Right, it's off, so it should now be printing. I can see something extruding. So the very outside pattern on that is the skirt, which is there to purge the nozzle and make sure it's flowing properly. And also shows you where it's printing on the bed, so you can immediately see if you've somehow sliced it off the edge of the bed. But in this case, obviously the part is quite small, so we should be fine. And now it's actually doing the part in the middle of that, so the part is a little bit smaller than the very outside extrusion. We're a few layers in, so it's done some solid layers, and then we should get some sort of infill. I selected the standard print profile, so it's not going to make a totally solid piece, and it should print at average speed. You can see the fans they're running. The one that's in the middle there is automatically always cooling the heat break on that cold end of the extruder. The other one on the side there is cooling the print, so that's actually running as denoted in Cura. There's some cooling settings, but in this case I think it gets faster and faster as the print goes up, so that it cools details and makes a better quality print. You should be able to see now that it's done the solid bottom layers. It's now doing a lower density infill, which I think is 20%. So that's doing a very sparse infill pattern, which makes the print lighter and still probably just as strong, and obviously quicker, and uses less material. And all those settings are specifiable in Cura in the Advanced tab, so you can make it solid if you want, or hollow if you want, or whatever. We're getting there. It would appear a Rocktopus is emerging. Only a few more minutes left to go. We're nearly there. It says 99.4%, so it's only got the very top surfaces to do. Those cooling fans are speeded up quite a bit now, which is helping with the two fingers sticking up there on our Rocktopus. So hopefully 99.6. We should find that the print will finish completely. There we go. 99.8, and it's just the moves left in the G-code to move the head away now. And that basically leaves the print completely finished. The bed is now cooling. It's got a target temperature on the screen of 50 degrees, and it's currently just cooling down from 85. It's in the mid-70s at the moment. And I think once that's done, it should home the extruder here, and the bed should move forward to tell us we can remove the print. There it goes. So the bed is now down, and it's cool enough to remove the part. So the bed on this one is PEI, which is a bed you don't